Okay, so now that we know how a particle works, let's look at the emitter. Now the emitter is basically the origin point for all of our particles to launch from. So this could be a visual element like a volcano or something like that, or a fountain, or a firecracker or something like that within your game. Or it could just be completely invisible. Maybe you have it following the mouse. Whatever it is in your game, it's up to you. But for us, what I've done is I've built in a system that allows you to either have an image for the emitter, or just ignore the image completely and just have a null value or a nothing value for the emitter image, in which case it just won't draw it, which is great. So it's completely customizable, up to you. And of course you can modify this however you want. I'm just giving you a rough outline of a basic particle system. So if you need to expand upon this, that's the ball's in your court at that point. So let's take a quick look about how the emitter works. So basically, first thing I've done is I've created a constant value called explode, and this is going to be used for in place of a launch frequency when the programmer wants a quick explosion that explodes all the particles at once, like a firecracker or an explosion or something like that within the game. It's up to you. And usually this is a non-cycled thing, but again, maybe you want that explosion to be cyclable. I don't know, it's up to you. So anyways, and notice this is public, and that way when you're building your emitter inside the main class, you have access to this to say, hey, I want an exploding emitter. So for our data that we're going to be setting up, again, not everything that is one of the parameters for the constructor exist up here in variables. Some of them are calculated and whatnot and reassigned or randomized and all that fun stuff. So our emitter data. Basic stuff, basic properties are about the emitter itself. So the image that's used, this may be a null value when you're creating it, that's fine. Destination rectangle, where is the emitter being located? Number of particles in the emitter, this might be 5, this may be 5 million, I don't know. Test it though, because the more particles you add, the more intense it is on the CPU. Launch frequency, how often do you want more particles to launch? How many milliseconds need to pass before you want more to launch? Now obviously this number needs to be somehow in sync with your frame rate. So if your FPS is 30 frames per second, that means you're not even going to get, you're going to be looking at a minimum of 32 milliseconds passing before the next update comes along, right? So if you want it faster than that, then you need a higher frame rate. Particles per launch. So when it is time to launch, how many particles are going to be launched at that time? Cycle particles, just a boolean saying, yep, should I recycle the particles, or once they're dead, that's it. Active is the emitter currently launching particles. Launched, that just represents, that's used during explosions, and basically, have I exploded yet or not? Time passed, that's used during, well, a few other places. We'll get into that in a bit. Particles dead, particles alive. Again, that tracks how many particles have died during the process and how many particles are currently alive, which means there still may be some that are neither dead nor alive yet that just haven't been launched. So that's where there's really 3 states for a particle to be in. Then we have an array list of particles. So if you have, well, you should have gone through this by now, but the array list is just basically an expandable, a resizable array that grows and shrinks as you need it. Particle image, obviously, so now we're in a particle data itself. The particle image, how wide and high, the size of the particle itself. Transparency level, whether the particles are collidable, gravity, wind, all the basic stuff. And then the range data. Now this is also for the particle, but this allows us to set up and customize our various ranges of our emitter, and this is really where the magic happens that allows us to customize what the particle system will look like. So a low angle and a high angle. So for example, if I was creating a waterfall that's kind of falling over a cliff edge that's going over to the right, then I might have an angle between like 0 and 12 degrees or something like that. So it's a very shallow drop point. Speed, how fast you want it to explode out of that particle or out of that emitter location. If it's meant to be like a very fast projectile, then you want that speed to be very quick. And again, that's how many pixels per second the particle will move at. Low lifespan, high lifespan, what range of life do you want to have? Do you want it between 1 and 2 seconds, so 1,000 and 2,000 milliseconds? That's up to you. So those are all the basic data we have for an emitter. So the constructor just basically sets up all that data, so store all the data passed in from the constructor. So it's an image, destination, rectangle, particles, launch frequency, particles per launch, cycle particles, collidable. This is data that is not actually passed in active, so it's going to start off as inactive, so it's not going to be launching anything. No time has passed yet, and it creates the array list with the number of particles that we previously set up here. So now it knows how big to make the array list. If emitter image was given, so it's not null, so it does actually have a value, then we need to set up the destination rectangle of the emitter image to match the destination rectangle that was passed in, so that way they're on the same location. Otherwise it'd be pretty ridiculous. The particle image data, again, this is data that's passed in. We're just going to store that data as it was given. Again, the transparency is capped between 0 and 1. That way it doesn't fall outside of acceptable values. And then the range data is stored. Now down here, these next two lines, they do something a little bit special. Now you don't have to have this in your program, but I've chosen to put it in here. And basically what it does is it finds the center point of the emitter, and it tries to line up the particles at that same center point. That way it looks like the particles are launching from the center of the emitter. Now again, this is up to you whether you actually want this in your game. But if you don't have it, that means they're basically going to launch from the top left corner of your emitter, which might look pretty awkward if you're drawing an image for the emitter. So be careful about that. It's up to you. And then basically we create each particle. So we call the constructor for the particle for every one of the particles. And we just pass in all the data. I get a copy of the sprite sheet, not the original sprite sheet itself. So every particle gets its own sprite sheet. The gravity and wind is just passed in. Now we randomize our angle, we randomize our speed. Just make sure that we have that in the proper order. I hope I didn't confuse that. Angle and speed, yes, okay, sorry. So we randomize our angle, then we randomize our speed, then we randomize our lifespan. We set the transparency, we set the collidable particles, and this down here is just creating a rectangle that represents the screen bounds for collision. So it starts at the top left corner, oops. It starts at the top left corner and it goes for the width and the height of the screen. So that's how we create each particle. So that's pretty straightforward. There's nothing special there. It just does it for each one. So now we get into how the particles update. Now you can see the bulk of the work here is done in update, because a particle can update in a few different ways. First of all, we don't update anything, or sorry, the emitter can update in a few different ways. We don't update anything unless the emitter is active. We just don't do anything. However, if it is active, we got to look to see what kind of particle system we're creating here. So for example, if it's an explosive particle system, we know this because the launch frequency is set to explode and it hasn't launched yet. So in which case we're going to set launch to true because we're about to launch everything, and then we're going to go through every single particle in the particle system and we're going to launch it. And as long as that launch was true, we're going to increase number of particles alive. Now, sorry, I've went backwards on here. What I had there is an acceptable way of doing it. It just does something a little bit differently. I'm not really going to get into the details about that right now. But basically, just add 1 to the particles alive integer. So that's for if it's an explosive particle system. If it's not an explosive particle system, which means we have a launch frequency of greater than 0, then we're increasing how much time has passed, and we are going to, if enough time has passed, we're going to launch more particles. That's what the whole point of the time passed is. So if enough time has passed, we're going to launch some more particles. So basically, if it is a recycling particle system, we're definitely going to launch particles, no matter what. However, if it's not a recycling particle system and we still have particles to launch, so the dead plus alive is less than num particles, there's still some particles out there, then we're going to launch another particle. We're going to reset time passed back to 0, and we're going to launch particles. Okay? So this is an OR statement. All right? So if it's cycling, we're definitely launching a particle, no matter what. However, if we're not recycling and there's still particles left to be launched, launch some more particles. So that is for a regular, this is the standard way of doing things. So once we've decided to launch all these particles, let's start moving the particles that have been launched. So go through every particle, and we're going to update that particle. And that we're just going to call the update code from the particle class, and we're going to pass into it the current center point of the emitter, because the emitter may have moved, and we're going to pass in how much time has passed since the last time we updated. And if this did not update for some reason, sorry, not if it didn't update, if the update returns a false, remember that false means that the particle died during its update, then we got to kill off the particle. So we're going to re-randomize its trajectory. And again, I put my pluses on the wrong side here for you guys. Sorry, I don't want to confuse anybody. We're going to re-randomize the trajectory to give it a new trajectory. And then we're going to increase the number of particles that are dead. Okay, because we just killed off a particle because the update returned a false. We don't have to do this if the update returns a true, because we're not killing anything off. And then we continue on. Now remember, this goes through all the particles. So now we need to check to see if we're at the end of a non-cycling particle system, because if we're at the end of a non-cycling particle system, we're just going to reset the particle system and not do anything else. The reset for the emitter will actually deactivate it, which we'll get to in a second. So if it's not a cycling particle system and the particles dead is greater than or equal to the num particles, so we've actually got to the end, then what we're going to do is we're going to go through all the particles, we're going to reset all those particles, and we're going to reduce the particles alive. So by the time this is all done, particles alive should be back to 0. And then we reset the particle system itself. So that's update. So we update for explosions, we update for regular particle system, and then we actually move our particles, and then we check to see whether the particle system still is alive. Draw just basically goes through, if the emitter is active, it will draw all the particles, and if there is an emitter image to draw, it will draw the emitter image. To start the emitter system, basically all we do is if it's not currently active, reset the system just to make sure, activate it, so start doing stuff, and if there is an image, if there is an emitter image and that emitter image is an animating emitter image, it has more than one frame, then start the animation. That's it. That's how we start. Reset just goes through and resets all the important data. Resets the time passed, resets the particles alive, resets the particles dead, deactivates the particle system. It stops any animation if there is one playing, and it sets launched back to false to make sure that the explosions can occur again. So that's reset. Launch particles. This is actually pretty straightforward. If it's time to launch some particles, how many do we want to launch? So basically this just goes through a for loop, and it will go through and remember that our num particles, because as programmers we may have accidentally put in a launch particles, like a quantity to launch that's greater than the number of particles that exist. That could be a problem, so we have to account for that. So basically we're going to go through a loop that goes through all the particles. It'll keep looping as long as we haven't exceeded the number of particles, and the number of particles we've launched so far is less than the desired number of particles. So if that's true, then we're going to check and find the first inactive particle. So if I is inactive, launch it. And if we launch it successfully, increase the number of launched and increase the particles active. The number launched here is this quantity right here, so we're just keeping track to make sure that we've actually launched enough particles. When all those are true, we're all done. And then we just have some basic helper functionality down here. Returns whether the particle system is currently active. It returns the current position of, sets the current position of the emitter. This allows us to move things around. Say, for example, we want the emitter to follow our mouse or something like that, or it's moving along the screen for some reason or another. It's up to you. Maybe you have like a flame that's kind of moving down like a TNT wire or something like that, like a wick. It's up to you. And then basically that just moves its location and resets all the appropriate particles to launch from that location. And then get particle launch point. This is what finds the center point of the emitter, and then it centers the particle on that emitter using its width and height, and then returns that vector to the proper location. And that's it. That's the entire emitter class. The next piece is just to tie everything together and get it to work.